Okay, so as always, this live session is being recorded. So if you unmute yourself or if you unmute your camera, that will be recorded as part of this live session. All right, so today we are going to be talking about section 3.2. Let me just remind you of what we have going on this week. Our quiz opened this morning at 12 a.m. And it will remain open for the next week. So it'll close on September the 16th at 11:59 p.m. So that's right before midnight. So Wednesday night, right before midnight. So y'all, today I have been struggling trying to figure out how I was going to get this calculator situation to work. I have bought this document camera, which just records basically, like I could sit my calculator under it and record everything. But my laptop decided not to work this morning. So I got to take it back to get worked on, and they couldn't get over here from tech services to download the software onto my laptop. So we're just going to work with what we have today. I just want you to know that in the future, hopefully starting, I don't know if they'll get here by tomorrow, but definitely next week, I'll have something better set up, a better sort of situation so that you can see my entire calculator as I'm showing you how to use it. So today, let me just show you what we're going to be working with. Hopefully you all have your graphing calculator with you today. If you don't, that's okay. You can always watch this video back later whenever you do have your graphing calculator to review the steps. Your textbook also has some resources that I'll show you in a little bit. They have some like step-by-step guides for how to do this stuff in the Texas Instruments calculator. So I just wanted to share my screen with you really quick, just so you can know what to expect today with the calculator. So this is the only thing I could come up with, unfortunately, is I have this TI Connect software on my computer, and it'll let me capture my screen of my calculator. So you can see if I type in something, you'll be able to see what I type in. Now, the downside to this software is that you cannot see what buttons I'm pressing. So I will make sure and go slowly and make sure that it's clear what buttons you should be pressing whenever we are going through the steps. All right, so let's go ahead and open up our whiteboard for today. Today we're looking at section 3.2, which is called Measures of Dispersion. So measures of dispersion, what that means is that we're going to be looking at how data sets are dispersed or how they are spread out. All right, so dispersion means like how they're spread out, how the data values are spread out. All right, so yesterday we looked at the measures of center, which told us like the average. Today we're going to be looking at how the data are spread out. Or dispersed. The three measures of dispersion that we'll talk about today are range. That's the easiest one to calculate. And then we'll look at variance. Now, in real life, you don't really use variance that much. Instead, you will use standard deviation more often. But the reason that we have to talk about variance is because you have to calculate the variance to find the standard deviation. So the standard deviation is based off of the variance. So that's why we have to talk about variance, even though, like I said, it's not really used that frequently in real life. Okay, so let's talk about the range. This is going to be the easiest one. Now, the range and the mode, those are the two things that your calculator will not compute for you. So you have to calculate the range. Now, what the calculator will do for you is it will tell you the maximum data value and it will tell you the minimum data value. And so you can just plug it into this formula, but it's not going to have an output line that says like range equals 2 or range equals 10. So we're going to have to find the maximum data value and the minimum data value, and we're going to have to plug them into this formula. Now, don't forget, I do have a formula sheet for this section. And again, you can find it just by going to content. And I think it's under Unit 2. I can't remember the name of the folder, but it's like the second folder down or something like that. All right, so let's look at an example of the range. You can see this example I've got here is the same exact example that we went through yesterday. So it says, first I should read the formula, right? It says the range is a measure of dispersion that is the difference between the largest and the smallest values in the data set. So the range is equal to the max minus the min. So range equals maximum minus minimum. All right, so let's look at this example. Students were surveyed to find out the number of hours they sleep per night during the semester. Here's a sample of their self-reported responses. Calculate the range. Okay, so typically if I have a small data set like this, I don't worry about plugging it in my calculator to find the range. But if you really wanted to, make sure that you didn't make any mistakes, you could do this in the calculator, and I'm going to show you that on the next example. All right, so the range is equal to the maximum minus the minimum. All right, so maximum is, do y'all see that, 10? And what is the minimum? 4. 4, very good. I like the little beep, beep, beep before that too. All right, so 10 minus 4. All right, so the range is 6. So the range is always going to be a number. There we go. Now the range, just depending on the types of numbers you have in your data set, the range could have decimals in it. It's okay if you get a question and you have a range that's like, say, 6.2 or 6.01. That's totally fine. It just depends on the types of numbers you have in your data set. All right, so let's look at, I'm going to talk about the variance, and then I want to show y'all an example where we have to compute the variance. It's kind of, there's some extra work we have to do after we plug it in the calculator, but I'll get to that in just a minute. So variance. Now, variance, these are one of the most common measures of variation, but like I said, variance isn't really used that often. Standard deviation is what we will see used most often, but in order to calculate the standard deviation, we have to calculate the variance first. Variance, again, is just going to tell us how spread out, let me get my pen here. Variance is going to tell you how far away the data values are from the mean. So the range is just going to tell you, how spread out the biggest one is from the smallest one. The variance is going to tell you how far away the data values are from the mean. So with that said, if you have a larger variance, that's going to mean that your data values are farther away from the mean. And then similarly, a smaller variance would tell you that the data values are closer to the mean. So again, variance is all about variance, range, standard deviation. These are all about measures of dispersion. So telling you how much the data values are spread out. So a larger variance would indicate that the data values are farther away from the mean. Smaller variance, data values are closer to the mean. Now, typically, it's okay to have a really big variance. So you might get a variance when you're doing some of the problems on the homework. You might get a variance of like 144, or you might have a variance of 0. It's all, there's no wrong values to get for the variance, except you cannot have negative values. So whenever you're calculating the variance and the standard deviation, you should have no negative values allowed for it. Well, I shouldn't say allowed, because we're going to see some examples in the data set that do. Some of our data sets are going to have negative numbers. So it's okay to have negative numbers in your data set. You just no negative values for the variance. You just can't have, you can't get your answer for the variance and it be a negative number. That would be, you did something wrong there. And I'm going to show you in just a second why you couldn't possibly get a negative value. Now, this is the formula for the variance if you are computing it by hand, and it takes, basically what you have to do is you have to make this big table, because look at our first formula here. It says the population variance is given by, and notice again we got this Greek letter. Remember, whenever we were talking about the population, they use these Greek letters. This is the Greek letter sigma. This is a lowercase sigma. Remember yesterday we talked about the uppercase sigma right there. That's also sigma, it's just an uppercase. It means sum. So again, this symbol here means sum. So the variance is given by sigma squared equals the sum of all of your x values minus the mean. Remember, this is mu, the population mean. So all of your x values minus the mean squared. And think about what happens when we square a number. If you take like 2 squared is 4. Well, negative 2 squared, that's negative 2 times negative 2. That's also positive 4. So that's why we can't have any negative numbers, because even if you square a negative number, it's always going to come out and be positive. So it's not possible for you to get a negative answer for the variance, because it's got this component in here where it's being squared. All right, so we're having the sum, we're taking up the sum of all the x's minus the mean squared, and we're dividing that by capital N, where N is the number of values in the population. And I just want to point out the differences for the formula with the sample variance. Again, we're using an S from our regular alphabet. So if you're talking about the sample, they use the letters from our regular alphabet. So S squared equals the sum of all the x values minus x bar, which is the sample mean. X bar is the sample mean squared, divided by the sample size minus 1. And I can go into and show you why you have to do n minus 1 down here. But let me write sample size. It's hard for me to write and talk at the same time. But the reasoning is because it has to do with some theoretical aspects of the variance, and basically whenever you are calculating the variance, there's going to be one data value that has no choice but to equal a certain value, because all of the x's in our data set, they have to average out to equal this x bar. So it's not important that you know why we divide by n minus 1, but if you are interested, I could show you some really cool proofs of why the variance has this denominator of n minus 1. Now, like I said, these formulas are terrible, and if you're doing this by hand, it takes forever. If you're in my quantitative reasoning class, you probably remember I made you do this by hand. I'm so sorry. And this is a terrible formula. It takes a really long time. Basically, what it ends up happening is if you have to do this by hand, you can only have like 5 or 6 data values. Otherwise, the problem just takes too long. All right, so I'm going to start talking about standard deviation, and then we'll do an example. Because all of the examples you're going to see in the homework they're going to ask you for the variance and for the standard deviation in one example. So I just figured we'd talk about both of these first and then do an example. All right, so standard deviation. Now, like I said before, standard deviation is based off of the variance. And this is the way the formula works. The standard deviation is equal to the square root of the variance. So the reason that you take the square root is because if you remember back in this formula up here, I'll scoot back down in just a second. If you remember, we squared everything to make it positive. So this sort of undoes that squaring process, and it brings it back down to a number that is closer to our data values. All right, so this process here where we take the square root of the variance to get the standard deviation, that's all based around the fact that we had to square all of those deviations. That's what the inside of this parentheses is called. It's called the deviation. All right, so these are the formulas, and you'll notice they are the exact same formula. They just have the square root in them. And notice that when we're talking about the standard deviation, remember with the variance, we had sigma squared. Now with the standard deviation, it's still that same Greek letter sigma, but no squared because we took the square root. So the square root cancels out the square. All right, and then again for the sample standard deviation, instead of having s squared, we have s, and we have the square root of our variance under here. So this whole inside portion is the formula for the variance. So that whole inside part, this was the formula for the variance. Okay. All right, so I'm going to switch over here to Hawks, and we're going to go through an example together, and then I'm going to come and do this example right here. It's already logged me off. I'm sure y'all know if you, I don't know if it's like this for students, but on my Hawks account, if I don't do anything for like 5 minutes, it logs me out. All right, there we go. I don't want to do that one because it's got a special data set. Let me find a good one. Cool, there we go. All right, so this is from the practice portion of section 3.2. It says, calculate the range, population variance, and population standard deviation for the following data set. If necessary, round to one more decimal place than the largest number of decimal places given in the data. All right, so let's look at our data here. These are all whole numbers. Okay, so that tells us if we have to round to one more decimal place than what we have going on here, that tells us that we should round to one decimal place. All right, so let's start by finding the range. Range is super easy. Let's see, find the highest data value or the maximum and the minimum. So maximum is 20 and minimum looks like 6. So the range would be 20 minus 6, which is 14. Now let's look at population variance and population standard deviation. So get your calculator. I'm going to go over here to my TI Connect app. All right, so you should start off on your home screen. Let me see if I can spread this out a little bit. Okay, so start off on your home screen. It should be cleared out. So this is what my home screen looks like. I'm using the TI-84 Plus CE, which is I think it's the newest version of the TI calculators, or the newest version of the TI-84 anyway. You're going to start by pressing the STAT buttons, S-T-A-T. So it's located, it's in the middle column, right below the delete button, which says D-E-L. So the top, it says zoom, down one, it says delete, and then stat. All right, so if you press the stat button, this is what it should look like. Did everybody find the stat button?
Yes.
Cool. Okay, so right now, depending on if you've, like maybe you borrowed this from a friend, your Thank you everybody for letting me know. Depending on if someone has used this calculator before, you may have some data already in your calculator. That's okay. So right now we're going to go to edit because we need to put our data in there. So you see the first option there is edit. So you're just going to hit enter. So this is what my screen looks like. I've got some data in my L1 column. Now it's very important. I want everyone to look right now at the top of the screen here. It says L1, L2, L3, L4, L5. Is anyone missing one of your columns, or does everyone have the columns in order, L1, L2, L3, L4? Okay. You can delete these columns. Let me show you what will happen. If you go up here and you press the delete button, so look how I have the L1 highlighted up here at the top. If you go up there and press the delete button, look what happens. It deleted my whole column. You do not want to do that because that's going to mess up your calculations whenever we go to calculate the mean and the median, standard deviation, stuff like that. Rhonda, you don't have L4. Use the right. Alexander says use the right arrow. Yeah, your screen may be a little bit different than mine. Okay, cool. Robin, are you missing anything? Okay, cool. All right, so let me show you, if this ever happens to you, let me show you how you can get L1 back. You press stat again. Takes you back to the home page or back to the main screen of stat. Then you scroll down to setup editor. Now, again, I'm only doing this because I just deleted my L1 column. You don't need to do this if everything was showing up for you. So if you accidentally delete one of your columns, you go to setup editor, you hit enter. It's going to take you back to the home screen. It'll say setup editor. You just hit enter again. It'll say done. And then now let's go back to my stat screen. And I'm going to show you the L1 column will pop back up. So again, I'm back at my stat screen. I hit edit and there it is. So it pops back up. Now, normally if this was a face-to-face class, it wouldn't be important that you know how to do this because I could just fix your calculator when you're in class. But if this happens to you during a quiz, then just know how you fix this is you go, like I said, go back to stat, go to setup editor, press enter twice, and then it'll make all of your list show up again. So this is list 1, list 2, list 3, and so on. Okay, so now that I've went off on a tangent, let me show you how to clear out your list. So right now I have a bunch of data in my calculator and I need it to go away. So I'm going to scroll up to the very top and notice how my L1 is highlighted. So it's got the highlighted portion is on the L1. Then you hit clear, enter, and that is going to clear out your entire list. So you have a blank list to work with. All right, so does everyone have a blank list? Yes, okay, good. Thank you all for telling me. Y'all are so awesome. All right, so we're going to start typing in our data. So starting with 14, let's go down the line. You're going to hit 14 and then enter. That's going to take you to the next row. So start typing in your data and be careful because if you mess up one of these, it's going to mess up your answer. So 14, 12, 18, 10, 8, 6, 15, ooh, 15. I just messed up and I typed 515, so that would have definitely messed up my answer. All right, so 9, then 16, and then 20. All right, so 10 data values. All right, so this is what I've got going on right now. I've got all of my data in here. Now that your data is in here, you're going to go back to stat. So hit the stat button again. It'll take you back to this main menu. And then look up here at the top, see how it says calc right there, C-A-L-C, calc. That means calculate. So that's where you're going to go anytime you need to calculate something. So go over to calc, make sure that's highlighted. And then it's got a bunch of options here. We're going to do one var stats. That means one variable statistics. All right, so hit enter. My calculator pops up with another option here. It says list, and then I tell it what list I used, L1. Frequency list, I don't have anything in there. And then you hit calculate. Now, if you have the TI-83, this may not pop up for you. It'll probably just go straight to the home screen, and that's fine. You don't need to do anything else. All right, so I'm going to scroll on down to calculate. I'm just going to hit the down arrow until I'm at calculate. It didn't show it for some reason that I'm highlighted on calculate. It's blinking, I guess that's why. Then I'm going to hit enter, and then boom, there's everything. And makes your life so much easier if you do this. Now, you can use the down arrow. It's going to tell you a bunch of stuff. See how it says min X? That's the minimum value. If you scroll on down, you'll see MED. That's the median. So you see MED right there. That's the median. If you scroll on down, the last option is, it tells you the maximum value. So that's how you could do the range. You could say maximum minus minimum. So 20 minus 6 is 14, which we found already. But the part that we need right now is closer to the top. So the first thing it asks us to find, it says to find the population, very important that you note the wording here, population variance, and then the population standard deviation. All right, so scroll on up to the top. Please interrupt me if you need me to tell you anything about the calculator. If you hit the clear button at this point, it's going to make everything go away, but that's fine. You just go back to stat, over to calc, hit one var stats again, and it'll pop right back up. All right, so if you go back up to the top, I'm back at the top of my one var stats again. Notice the very first option is the mean, and then it says the sum of the x's. We don't need to know that. That's not important. We also do not need this second line, the sum of the x's squared. What we're going to use right now is this line right here where it says sigma x. That means the population standard deviation. Okay, so the population standard deviation. So the population standard deviation is 4.331281566. Right above it is SX. That's the sample standard deviation. Now, this problem asked us for the population standard deviation, so we're going to use the one that says sigma. And remember, we're supposed to round to one decimal place, so that's 4.3. So go down here to the population standard deviation and hit 4.3. We're typing 4. Sorry, you have a different problem. My bad. Now, for the variance, if you remember, let me go back to our whiteboard. The variance, if we just use some stuff from college algebra or from whatever last algebra class you took, this relationship here implies the following. This tells us that the variance is going to be equal to the standard deviation squared. So you take your standard deviation, I'm going to put it in parentheses here, and square it. So that's how we're going to find the variance here. So it's kind of a little cheat so that we don't have to do all that extra work to find the variance. So we're just going to use what we know the standard deviation is, and we're going to square it. So let me pull back up the homework here. So again, variance is equal to the standard deviation squared. So here's my calculator. I'm just going to hit the clear button to get back to my home screen. All right, so now I got a blank screen. All right, so if you see my last screen here, this population standard deviation, I'm just going to type in a couple of decimal places here. So 4.33128, just so I make sure that I don't miss anything. And now I'm going to square that. So does everybody see the squared button on their calculator? It's sort of catty-cornered to the 7. If you have a TI calculator, if you have a Texas Instruments calculator. This is what, yours may look a little bit different if you have the TI-83. It'll look like a little caret and then a 2. A caret is like an upside down B. All right, and then you just hit enter, and there is the variance. 18 point, remember we're supposed to do this to one decimal place, so 18.8. Let's check our answer. That's great, Jamie. So we got this correct. What do y'all think? Is this okay so far? I know that we've only done it once. We're going to do it a couple more times today. But what do y'all think? Is this okay? So the steps you need to remember, if you just did 4.3 squared, it would give you 18.49. Let's see if that would work. I'm going to type this in my calculator really quick and see if it's, so always do a couple. Let me check, Rebecca. I'm going to type this in my calculator and see if just doing one decimal place would work. Give me just a second. Okay, so I just typed in this problem, or typed in this data set, and this is what I got for the variance. It's 4.05. If we do 4 squared, 4.0, I guess we would really round that to 4.1, right? 4.1 squared. Let's see, that gives us 16.81. So let's see if that'll work. $16.8 range. Let's see, the highest is 18, lowest is 5, so that's 13. And then that was 4.1. Oh yeah, that works. So it's okay if you just round to one decimal place. It looks like that's fine for Hawks. But on the quiz, you're welcome. On the quiz, you know, it's going to be multiple choice. So you want to just kind of, you know, think about, you know, if you get something a little bit different, just think like, okay, well, maybe she rounded to 2 decimal places. Let me try that and just see if you can get the right answer based on the choices that you have listed there on the quiz. All right, now let's look at the next example. Back to this problem again about the number of hours that students sleep every night. Last night, I think I slept like 13 hours and it was, no, yeah, I think it was like 13 hours. I can't remember. Anyway, it was freaking awesome. My husband got up with our baby this morning. It was so awesome. So we're going to take our data set. Let's go back to our calculator here. Yes, it was honestly like, it felt like it gave me life. I didn't even need coffee this morning. All right, so we are going to, I didn't wake up groggy. No, it was like, I was like, I feel like I could literally do anything right now. I could run a marathon. That's how I feel right now. I feel like I haven't slept. I know I haven't slept that long since like 2 months before my baby was born. So it was awesome. All right, so we're going to do a new list in our calculator. So let's go back to your home screen. I always like to start off with a clear home screen. I like everything to be cleared out before I begin. So I'm starting off with a blank screen. I'm going to go to Stat, and then I'm going to go to Edit. Right now, you should definitely have data in there if you just did the last problem with me. So we need to clear this out. So scroll to the very top, make sure that L1 is highlighted, and you're going to hit Clear, Enter. Clear, Enter. So clear is the last row on the right, and then Enter is on that same row. So clear, Enter. All right, so everybody got your list cleared out, or anybody still trying to figure out how to clear out their list? Okay. let's type in this data. One thing that sometimes people will ask is, do you have to type it in order from smallest to biggest? You do not. You can type it in any order. All right, so we're going to start off 5, 6. Let me show you my calculator screen. 5, 6. Whoops, sorry, I covered up the data. 5, 6, 8, 10, 4, 6, 9. Okay. Ooh. All right, so this is what my screen looks like right now. 5, 6. I always try to look over before I go back to stat and over to calc. I try to just look over my data and make sure everything's in there correctly. So 5, 6, 8, 10, 4, 6, 9. Yeah, that looks right. All right, so back to stat, hit the stat button again. All right, and then go over to calc, calculate, and then hit 1 bar stats. All right, so I'm at 1 bar stats, and I'm going to scroll down to calculate, and then I'm going to hit enter, and there's my information. Now notice it does not tell us either way here. It doesn't say sample or population, so we need to dig a little deeper. Look at the sentence right before that. So right here, here is a sample. Oops, sorry. Here is a sample of their self-reported responses. So since we have that word there, sample, that tells us, okay, we should use the sample standard deviation. Now, all of these are whole numbers again, so we should round to 1 decimal place. So our sample standard deviation would be 2.2. So we look to the 1 place to the right, that's a 9, so we should round this number up. So it'd be 2.2. All right, so S, whoop, you gotta press S, sample standard deviation is 2.2. Okay. All right. The more you do this, it becomes almost like second nature to calculate the standard deviation and stuff like that. So if you really get used to doing these steps, like going to stat, over to calc, to 1 bar stats. And this is something that we'll be doing for literally the rest of the semester. So, you know, this is something that you could write on your index card. You could write down the steps. You could say like, okay, step 1, hit stat button. Step 2, hit the edit, you know, put your information in the list. So just think about that for the next quiz, what you want to put on your index card. And then, you know, as we go through the semester, you probably won't even need to write it on your index card because you'll have the steps memorized. Some of y'all, if you were in my math modeling class, then you know we've done stuff like this with the list before, so you may be more comfortable with that. And maybe this will come a little bit easier to you. All right, I wanted to do this example because it's got negative numbers in it. So I wanted to show you that it's okay to have negative numbers in your data set. Just remember, the only place that you can't have a negative answer is you can't have a negative answer for the variance, and you can't have a negative answer for the standard deviation. And you can't have, yeah, I guess you could have a negative answer for the range. Let me think. If you had like negative. I think you also could not have a negative answer for the range. Yeah, I think that makes sense. But definitely you can't have a negative answer for the variance and for the standard deviation. Just keep that in mind. I think there's a question on, I keep mentioning that because I think there's a question on the homework that says like, it mentions something along the lines of like, would this value be okay for the standard deviation? And it says, yes, because any values greater than 0 or any positive numbers are fine for the variance of the standard deviation. You can even have 0 as your variance or your standard deviation. You just can't have negative numbers. All right, so let's look at this data set. It's -13, -13, 2, 2, -13, 2, and -9. Is it possible to have a standard deviation of -1 for some data set? No, you cannot have a standard deviation of -1. And the reason is because whenever you take, if you we go back to here, I feel like I'm about to sneeze. When you take the square root of something, we're always going to do this positive square root. So that's why the standard deviation has to be positive. That's a question on the quiz. Oh, on the practice quiz. Yes. Yeah, so on the practice quiz, I must have put something about, could you have a negative standard deviation? I haven't finished writing my answer key yet. I'm really slacking. Excuse me. I'm looking at the practice quiz right now. Yeah, I'm not seeing that question, but that doesn't mean anything. My practice quiz is everywhere right now. All right, so let us, on the 3.2 practice, I got you. On the 3.2 practice on hawks. I see. So one of these questions might say something about, could you have a -1? Yeah, I got you. Okay, so let's look at this data set. That's okay, Nikki. Let's look at this data set. Go back to your calculator, hit the stat button. Again, I'm starting with a cleared out screen. So this is what my screen looks like right now. Everything's cleared out. I'm going to stat. And right now I need to put my data in here. So I'm going to go to edit. So go to edit. And we're going to go to the top and hit clear enter. Clear everything out. So right now I have a cleared out list. Again, I went to the very top and I hit clear enter. Now I'm going to type in my data set. So -13, -13 again, 2, 2, -13 again, 2 again, -9. So just to remind you, your calculator will not calculate the mode for you. So if I'm looking at this, it looks like this is a bimodal data set. It looks like it has 2 modes, -13 and 2. All right, so here's my data set all typed in, -13 twice, 2 twice, -13 again, 2 again, and then -9. Now I'm going to go over to stat again. It's going to take me to that little main menu. Then we're going to go over to calc. And then hit one var stats. The first one, hit enter. Again, mine comes up with this extra list or extra page or whatever. So I'm just going down to calculate and hitting enter. So I'm hovering over calculate right now and hit enter. And there is my one variable statistics. Now, let me go back to the question here. It says the sample variance and the sample standard deviation. Okay, so sample means we're going to use our regular alphabet. Remember, population means use the Greek letter. So if we're using the sample, this is, again, the standard deviation would be 7.6. Okay, so that's the standard deviation. S is 7.6. All right, so if we're calculating the variance, remember, the variance is just the standard deviation squared. So that's going to be 7.6 squared. So again, I just checked on Hawks. Y'all saw me and it said it was okay, or it looked like it was okay to just use 1 decimal place. So I'm taking my calculator right now. Whoop, and I've just cleared out everything. I'm back on the home screen. And I'm going to type in 7.6 squared. So I've got 7.6 squared, hit enter, we'll round into 1 decimal place, that would be 57.8. All right, so again, the variance will always be larger than the standard deviation because you're multiplying the standard deviation by itself. So the variance will always be larger than the standard deviation, because the variance is where you take the standard deviation and you multiply it by itself. 7.6 squared means 7.6 times 7.6. So what this means here is 7.6 times 7.6. All right, now we need to find the range. I'm going to show you on the calculator how we would do that. So again, I'm here on this main screen. I'm going to go back to Stat. I cleared my home screen out, and then I hit Stat, and then I'm going to go over to Calc. I've already got my data in there, so I don't need to type anything in. I'm going to go 1-bar stats again, then go to Calculate, hit Enter, and now I'm back on this, I don't even know what you would call this, like the list of statistics. I'm going to scroll down to the very, very bottom, and this is what I'm looking at right now. So here's the maximum, here's the minimum. Max, the range again is max minus min. All right, so range, if we're asked to find the range. Sorry, I keep jumping back and forth. Range is equal to the maximum minus the minimum. Our maximum here was 2. Our minimum was negative 13. So notice I have 2 minus negative 13. When you subtract a negative, it becomes a positive. Remember, a double negative becomes a positive. So this becomes a plus. So the range is 15. Oh, and there's no special symbol for the range. You just write out range. So just like with mode, there's no special symbol for the range. Excuse me. Okay, so that is all of the calculator stuff we're going to be doing today. I think I have time to go over interpreting standard deviation and then the empirical rule, and then we will do the Chebyshev's theorem. We'll do that tomorrow at the beginning of class. All right, so interpreting standard deviation. Now, there's a question on your homework about this. I wanted to see if I could find it. Sign me out of Hawks again. Hopefully you're all doing well with Hawks. I know some people don't like it because of the learn part has a lot of reading, which I know can be aggravating. I just want to point out one more time, be very careful when you're doing these questions on the homework. Let me make this side go away. Let's see. I can't remember how to make that go away. Sorry. I'm just looking on the right-hand side right now. These are the questions that are on your homework. Be very careful when you're answering these questions. Make sure you're paying attention to the wording. If it says sample variance and sample standard deviation, or if it says population variance and population standard deviation. All right, let me scroll down to see the, oh yeah, here's the question that Nikki was telling us about earlier. Decide if the following statement is true or false. Is it possible to have a standard deviation? It is possible, excuse me. It is possible to have a standard deviation of -4. That would be false because standard deviation cannot be negative. All right, I wanted to show you this question right here. Excuse me, it says, Donna is looking into investing a portion of her recent bonus into the stock market. While researching different companies, she discovers the following standard deviations of 1 year of daily stock closing prices. Okay, so again, this is 2 stocks, and this is their standard deviation of their prices. So every day, I think the stock market's only open like Monday to Friday. So during those 5 days, every day they took the stock closing price, and then they took the average of that over a whole year. All right, Garden Statues Express, the standard deviation of the stock prices was 1.22 or $1.22. And El Lobo Malo, I'm so sorry if I'm messing that up, Incorporated, the standard deviation of the stock prices was $9.62. So your mind might automatically think, oh, okay, the second one is better because it's got a higher price. But let's look at the question it's asking. It says, based on the data and assuming these trends continue, which company would give Donna a stable long-term investment? All right, so let's think about what this standard deviation represents. Remember, the standard deviation is the distance from the mean. All right, so standard deviation tells you how far away those stock market prices are from the average. All right, so Garden Statues Express, it has a lower standard deviation. That means that most of the time the stock is pretty close to the mean. It's only $1.22 away from the average price, typically. And then the second one, El Lobo Malo Incorporated, it's got a higher standard deviation. It's $9.62. So that means that there's more variation, or there's the data values are more dispersed for that stock. So if you were investing in one of these companies and you wanted a stable long-term investment, you would want to go with this Garden Statues Express because there's less variation in the stock prices. So if you buy it at whatever price, say that you buy it at $39 per share, then in general, it's going to stay pretty close to that $39. It might go up to $40. It might go down to $38. But in general, it's staying within $1.22 of your purchase price. Whereas the second one, sometimes it might go up, but then it also might go down depending on the day. So the first one would be a more stable long-term investment. All right, so that's what I wanted to tell you about interpreting standard deviation. Let me get my pen here. A lower or smaller standard deviation. A smaller standard deviation means that there's less variability. Data values are closer to the mean. Whereas with a larger standard deviation, there's more variability. And the data values are farther away from the mean. So it's more spread out. Okay. All right, we're at 7:55, so I think I'm going to stop there for today, and we will go over the empirical rule and Chebyshev's theorem, as well as section 3.3 tomorrow. Section 3.3 is about measures of relative position. There's several, well, I say several. There's two formulas in that section, in section 3.3, that are very important, and this is something we're going to be doing on the project at the end of the semester, so you definitely want to make sure and watch that video or watch live tomorrow. And this stuff that we're going to be doing, this empirical rule and Chebyshev's theorem, they're not complicated, and once you see me do it, I think you'll be fine. But it's kind of complicated if you're reading it and trying to do it on your own. Let me switch back to my camera. Okay. So does anybody have any questions before? Let's see, today we talked about the range, we talked about this variance, and we talked about standard deviation. So does anybody have any questions about those three things, or about mean, median, and mode. I don't know if y'all saw, but the when you go to that 1-var stats, notice that the mean shows up there. So the mean, that was the very first option. Let me just show you on my screen again. I meant to mention that earlier, but I'm looking at my 1-var stats from earlier. And just notice that the top option, that's always going to be your mean. So -6 was our mean for that data set that was like -13, 3 times negative, or in 2, 3 times, and then -9. And then also you can get the median from this list as well. So if you scroll on down, see right here's the median is -9. So if you haven't done section 1.1 yet, you can totally just use the calculator to find the mean on all those questions, the mean and the median. You do have to do the mode by hand. You got to do the range by hand. And I think that's it. So what do y'all think? I know this is, if you haven't used this before, it can be annoying. Oh, thank you, Robin. That was nice of you to say. I'm glad that this was helpful. Some of y'all were in my stats class over the summer, and I did not do the live sessions, and I feel like that this class is going better because of the live sessions. So hopefully they are helpful to you guys. I know they're definitely, you know, it helps to just watch someone do it, even just a couple of times. So I'm glad that this is helpful. All righty. Thank you, Rhonda and Robin. All right, so I'm going to stop here for today, and I will see you guys at 12 o'clock tomorrow. And then next week, we'll be back to our normal schedule of Monday, Tuesday, Wednesday. So hopefully I'll see y'all tomorrow. You're welcome, Nikki. And I hope y'all have a great day. Bye.